Alrighty, let's have a look at the quiz here. The correct answer for number 1, 0.
Yeah, we know about wow. I got 37.
Oh yeah?
I got neither. I got X.
Okay, well, I don't know, there's something going on today. It doesn't matter. What we really want to care about is whether you get it or not. And if you don't get it, now's the chance to ask questions. Now's the time to learn it. Okay, so here we go. A 4 kilogram object is moving across a frictionless surface with a constant velocity of 2 meters per second. What does that say? The acceleration is 0. Constant velocity. Which one of the following horizontal forces is necessary? And the answer is 0, because Newton said an object in motion stays in motion. Nowhere in here does it say 2 newtons, anywhere. This says 2 meters per second. Units matter. Meters per second are not equivalent to newtons. The correct answer is 0. Objects in motion stays in motion. What is the value of FF? It's a 20 kilogram box sliding towards the right across the floor with an acceleration of 1 meter per second squared left. So it's actually, the acceleration is -1, and the mass is 20, and so the FF is actually -20. Mass of 20, acceleration of -1. -20. If you had 20, give yourself a half mark. Hard question. It's okay to get it wrong. We've learned that already. Say that again? No, F net equals FA plus FF. You add, it's the vector sum. It's just that the friction force is in the negative direction. Hey. No? No? You're hearing things, Mr. Burnett. You've gone crazy. Look at your outfit. You've gone crazy, man.
Yeah, I agree.
Yeah, dude, come to bed last night, Cole.
If the force is acting upon an object or balanced, the object must not be accelerating. Yay, a bunch of you got that right. We've talked about that already, right? If the forces are balanced, the object is not accelerating. There is no net force. The net force is 0. Martin, would you do me a favor? Because can you unplug that card and take the card into there? Would you mind? So that people can put them away that way. Maybe Chris will give you a hand. Okay. Stay focused, you guys. This is the learning part of today. Because now is the time to sit and listen and learn. It is not the time to visit. Now is the time to learn. A body of mass 15 kilograms rests on a frictionless surface and has 30 newtons applied to it. What acceleration is applied? Is there friction? No. What's my net force? 30. What's my mass? 15. F net equals MA. 30 is equal to 15A. What's the acceleration going to be? 2. F net is equal to MA. 30 divided by 15. Yay, lots of people got it right. A equals 2. A 20 kilogram object will encounter a 50 newton frictional force when pushed across a horizontal surface. With what force must you push the object in order to maintain a constant velocity? Is this one of those trick questions again?
Yeah.
It sure is.
Yeah.
Constant velocity means
0.
Acceleration is 0, which means the net force is 0. Is there a force here? There sure is. It's 50 newtons. How much force do you need? Plus 50. Plus 50. If the net force is 0 and there's minus 50 newtons of friction, you got to apply with 50. Why is it different than this one? Sorry, not 2, number 1. Why is this one 0? Because it's frictionless. In number 5, there is friction. So you have to balance that friction. An automobile has a mass of 1,600. What force is required to give an acceleration of 1.2 if there are frictional forces totaling 200? I remember doing a question like this. It had a picture of an ice cream truck. You put a star beside it? Correct answer? 2120. Yay, 11 people got it right. How do you get 2120? F net is equal to MA. We got a mass of 1,600. Our acceleration is 1.2. Someone help me out.
1920
Thank you.
plus 2.
1920. That's the net force. F net is equal to FA plus FF. 1920. What's the applied force? That's what we're solving for. Friction minus 200. Now, as Kieran correctly said, you have to add 200. So your applied force, 2120. Good for you if you got it right. I see there's a bunch of different answers here. I'm curious as to what those are. Does that make sense? What will its velocity be at the end of 8 seconds? Oh. What's the acceleration? 1.2. What will be its velocity at the end of 8 seconds? Acceleration is 1.2. A equals delta V over delta T. 1.2 delta V over 8. So the change in velocity is 1.2 times 8, which I think is it 9.6? Or 10? 9.6?
We got that wrong.
Oh. I can't do that in my head. Sorry. I should be able to do it in my head. I'm just choosing not to. 9.6, right. Therefore, the final velocity is 9.6.
Yeah, we said we got it marked wrong.
Oh, yeah? 16? 16 is not right at all. Where would 16 come from? Yeah, the acceleration would have to be 2, right? I apologize. The correct answer is 9.6. Give yourself a big check mark. That means the next one's going to be wrong too, right? How far will it travel in 8 seconds? Well, the first step is to go V bar equals VI plus VF over 2. So that's going to be 0 plus 9.6 all over 2. 4.8. V bar equals D over T. 4.8 is equal to D over 8. Multiply by 8. 38.4. Easy. Classroom filter.
43.
Yeah, so that one's wrong. I suck. But I'm okay with it. I made mistakes, I'll fix them. 38.4? Feeling better about that?
No, we got like 70%. We got marked for 70.
And the acceleration here, what do you have to do? You have to take, mass is 1, so I got a little fixing to do here. First step is to do what? Find the horizontal component. 50 times cos 25, I think it's 40.3, right?
45.
45, right, that's what I said.
Keep reading on.
And then what do you do?
Minus 5.
F net is equal to, look at me writing out the formula. 40.3 newtons, and because I told you the mass is going to be 1 kilogram, 40.3, the mass is 1, so you divide by 1, 40.3 meters per second squared. That's like a giant number, isn't it? 40.3 meters per second squared is huge. What did I have for an answer? Some stupid thing, right?
No answer.
No answer.
Yeah, we didn't get a check or
Oh, really? Okay, so I got some fixing to do.
Yeah.
I'll do that. Do you feel better about today? Do you feel like, hey, you know what you're doing, or did you learn something today? Because I don't know one of those things happen. This is a good day. There's a third option that you still don't know what's going on. You can still feel good about that because you're going to fix that mistake.
Mr. Bennett, we should boost up our averages for 5%.
I don't know if I can manually do that. If I can, I will.